Hello, students. So some of you who have taken Calculus 2 have seen some sequences and series, and in particular, you might have seen um, some sequences which are recurrence relations. So what do I mean by that? I mean sequences that are defined by a recurrence. This is the same as being defined, say, recursively. What would an example of that be? Well, let's say I tell you that a of 0 is 1, and a of n is going to be just 2 times a of n minus 1 plus 1. So this is what we would call a recurrence relation. And what do I know? Well, I know if I want a0, that's 1 because it's defined right there. But if I wanted, say, a1, what I'd do is I would take 2 times a0 plus 1, which is going to be 2 times 1 plus 1, which is going to be 3. 2 plus 1 is 3. We're doing some advanced stuff here. Okay, so, and I could keep going. I could find a2. a2 is going to be 2 times, well, the previous one, which was 3, plus 1. So 6 plus 1 is 7. So let's try to do this sort of thing in Python. And these recurrence relations are very easy to do in Python. All I do is I say, hey, return 1 if n is equal to 0, because that's our little case right here. And otherwise, we're going to return 2 times a n minus 1 plus 1. As a matter of fact, I almost wrote this in, uh, word for word. Okay, so now let's try this. Let's get the list of the first 10 values, starting with 0. So I get 1, 3, 7, 15, 31, 63, 127. I'm going to leave the math question. There's an obvious math question here. Can you come up with a formula to predict what each of these are? And then why does this recurrence give you that? So good math question, but we're going to stick to Python here. I'm going to go to a very famous, probably the most, well, most certainly the most famous recurrence relation of all time, and that is the Fibonacci numbers. So how did the Fibonacci numbers work? And sometimes the Fibonacci numbers are introduced through blocks and dominoes, or quite often little bunny population models. But probably one of the best ways is rhythm. And I could do many videos on Fibonacci and rhythm, but let's introduce it here just from one rule. What this does is it counts the number of ways that you can split up a certain number of beats into notes which take 1 beat and notes that take 2. And the way it's defined is that, and some people start it in a different place. Let's start Fibonacci of 1 equals 1, and Fibonacci of 2 equals 1. And then from then on, Fibonacci of n is equal to Fibonacci of n minus 1. So each one is going to be the sum of the 2 previous ones. So in order to get the Fibonacci number Fib3, I just take Fib1 and Fib2. And in order to get Fib4, I just take Fib3 plus Fib2, which is 2 plus 1. And by the way, I feel that I need to emphasize that this was not discovered by Fibonacci. He did bring this sort of math back to Europe, but this was known 200 to 300 BC by Pingala in India. So this goes way back. And it comes up naturally in many ways, but I don't want to go into a lesson on Fibonacci. Let's write this in Python. So I'm going to define this, and what I'm going to do is I'm going to return, well, I'm going to return 1 if n is in the set 1, 2. I could have returned 1 if n is equal to 1 or n is equal to 2. I could have also returned 1 if n is less than 3 if we're sticking to the positive integers here. But that's a nice way of doing it. Otherwise, we're going to return this. And let's get the first 10 Fibonacci numbers. I'm forcing myself to start at 1 here. So you see we get this 1, 1, 2, 3, 5, 8, 13, 21, 34, 55 sequence here. Extremely famous sequence here that comes up in math in many different ways and in nature.